Okay, this is a review video for final. This is semester 2 final in honors pre-calc, and this is not going to cover everything, but these are the smattering of topics that you ought to know. One of which is, I'll tell you that there's a fair amount of vectors on this test, which is good in the way because it's stuff that we did fairly recently. I mean, with the bowling ball lab, it was all about vectors. So if I told you this was a vector, I think for some people that's going to be confusing because they're so used to the equation form of it. Would you try to write me the equation form for that? That is a vector. But there's a way to write the equation form for that vector. Actually, write this on your iPad. Then I'll have you compare your answer with the kid next to you. Rows 1 and 2, in a moment you're going to be seeing if you got the same thing. Rows 3 and 4, rows 5 and 6. Except you two will compare. That's different. That's called a position vector. If you said 2i plus 1j, that's a position vector. That's not what I'm talking about. This is an equation. Equation has that deal where you have x over y equals starting point and the lambda. It doesn't have to be lambda. It could be t. Could be mu. Good. Either that you're trying to be a giant cat. I don't know. All right. So this is xy, and how do I know it starts at 0, 0? Because you have to have some reference point. It's moving this direction, but you have to start somewhere. But remember how if I actually do this and I say, okay, over 2, up 1, like it's moving in that direction, that this actually could be anywhere and be the same thing. Remember that? If it's got the same direction and the same magnitude as in the length of the little arrow, it doesn't really matter where it starts. But a logical place to start would be 0, 0. Plus lambda times 2, 1. Raise your hand if you had that one right. Okay, good. What's its magnitude? Figure it out. Pause for a second while you figure out this guy's magnitude. Once you've got the magnitude, I'm going to ask you to do something with it, but find the magnitude. Okay, you should have said that this vector's magnitude is based on just these two factors, and then you go square root of the 2 squared plus the 1 squared. So square root of 5. And it's kind of like just the length of it if you were going to draw it. Now, if it's in 3D, it's harder to picture drawing it, but you would have just done, if there was a third number like a 5 here, you would have done the square root of 2 squared plus 1 squared plus 5 squared. You would have just put them all together. All right. How many you had? The square root of 5 for your answer. Okay, good. Next thing is, that then helps you figure out the unit vector for this vector. This vector has a magnitude of root 5. A unit vector would have a magnitude of 1. Remember how to make the unit vector? It's got the little hat. Everybody make the unit vector for this. You can put it in column form or position vector. Either one. So you go back to this, and you make it a unit vector. I'll pause where you try that. I'm thinking that if I want to take its magnitude, I could just put the magnitude out front like this. Nah, that's not quite it. Its magnitude is root 5. So if I want to have it magnitude of 1, so it's the unit vector, I got to multiply by 1 over its magnitude. That way, it'll show that it's 1 over root 5 of its original magnitude. So this shrinks it down to be the right size. There it is. There's the unit vector. Okay. Now what if I said, now I want you to make it have a magnitude of 500? It's really not that hard. What do you just sit and do? Just multiply by 500. Okay. So you'd be surprised how hard this can seem on the test when they say it. And you're like, what are you trying to say? Okay. There's a lot of complicated ways to say. Test. There's a lot of ways to say this, but in the end, if you know they're telling you to make something a certain magnitude, that's a hint. You're probably doing that whole like find the unit vector thing. Yes? If you were going to put this, that's a good question. If you're going to morph this guy and have it be this thing, as it is, its magnitude is root 5. So if you wanted to, you'd have to squeeze in the 1 over root 5 right there, and yes, that could work. All right. And that would be a good kind of stretch question. At this point in the year, we're kind of reviewing mostly, so I don't think we'd probably do that to you, but that's what we should have done on the test. We might do next year. Okay, so now let's take this idea and move it one step further. We've got the same exact one, but now it's got a companion of m is a different vector, and it's at 2, -1. Similar, but different. The question is, what's the angle between these two? You'll have to do dot products. You'll have to do cosine of something. You'll need a calculator. It's a good question because it involves, does the kid know dot products? Does the kid know magnitude? Does the kid remember this formula? Does the kid be able to put all the numbers together and actually find it? So try that one. Find the magnitude, sorry, not the magnitude. Find the angle between these two vectors. I'll pause for a second while you try that. Here we go. You should have said it was cosine of this angle is the dot product over the magnitude times the magnitude. So let's save some time and get right to it. The dot product is 2 times 2 is 4, and -1 when put together make 3. True or false? Did I get that right? Okay, good. Just making sure. Then this other part is the magnitude and the magnitude. The magnitude of the first one is root 5, and the other one's also root 5. And that's kind of weird, but when you multiply them, you get root 25, which is 5. And so then cosine of the angle is 3/5. How do I figure it out from there? You use what on your calculator? Inverse cosine of 3/5. All right, good. Next, let's talk about inverse cosine for just a second. Let's say I just said, what is the cosine of some angle equals negative root 5 over 2, for instance. How would you do that without a calculator? Because they would say, I want the exact answer. Do you get the difference there? If you use a calculator, you're going to get a decimal. You're going to have to stop writing your decimal at some point, and therefore it isn't an exact answer. You know what I'm saying? You've rounded it. So, do you get how they gave you 2 sides? All right, I'm going to give you one more clue on this one. The cosine of the angle is negative root 5 over 2, and sine of that angle is greater than 0. That gets it narrowed down to only one quadrant where you could be. Let's see if you remember some trig. One more thing. This is not an inverse trig question, really, because I never wrote inverse cosine of negative root 5 over 2. Do you remember if it was an actual inverse from the start, there's certain restrictions on where those inverses can be? Again, I'm saying this problem is not like that, but do you remember how, what's that one that can only go from there to there? Sine. Nope. Cosine. Cosine is that one, and the other two go like this. You're only allowed to go from here to here, and it touches, what's that one? Sine. Inverse sine is only allowed from there to there. And how about the one where it's very similar, except it just can't touch? And that's tangent. Why can't inverse tangent touch? As it comes down to tangent graph has asymptotes, and those asymptotes are things you can't touch. It's like the MC Hammer of the graphs. So inverse tan doesn't touch there and there. So if this had been originally written as inverse cosine of negative root 5 over 2, do you get that would have had new rules? And inverse cosine only is allowed here and here, so I cross out these two. You get what I'm saying? All right. But this was not that way. So where can you draw it? Well, sine's positive is a big hint. That narrows you down to only two places possible. Okay? All students take calc. Where's sine positive? Up here. Therefore, that's out and that's out. Where is cosine negative? Well, it can't be here because they're all positive there. So that means I have to draw my triangle here. What are my sides? Cosine is adjacent, negative, root 5. Is that matching up so far? And hypotenuse of 2. What's wrong with this picture? Why isn't it possible? The hypotenuse has to be bigger than the other one. Do you get that this is negative 2 point something? Ooh, nasty. Another way to do it would be to figure out what this is, and do you get it would be negative 1 point something. Can cosine ever go below negative 1? No, it can't. No solution is the right answer for this one. They're trying to make you do one where cosine's going lower than negative 1, and cosine, the lowest it ever goes is negative 1. When's it going to be down here is what they're asking. It's not. All right, so let's do one that actually works like that. So let's say I had inverse sine. Let's do actually an inverse sine question this time. Of 1 over root 2. And I'll also say tangent of theta is less than 0. It's all about where that triangle is. Try to draw that triangle in the right spot and figure out its sides. Once you've got a labeled triangle, life is good and this will be easy. I'll pause for a second while you try that. In case you've forgotten this part, this guy's saying, I want an angle. Your angle is your answer. What is the angle is the question. Okay, so if I draw this picture right, tangent's negative. All students take calc. If tangent's negative, tangent would be positive here and there, and therefore those are out. Tangent must be negative, and therefore it must be either in S or in C. How about this? Where is inverse sine even allowed? In C. It's only allowed from here to here, and therefore that one's out. So therefore, you better be drawing it right here. How many of you are drawing it in the right spot? Okay, good. Then, from there, sine is opposite of hypotenuse. Opposites 1. Hypotenuse, just hold on. Hypotenuse is square root of 2. And now, all of a sudden, what's wrong? There'd have to be a negative, otherwise this is impossible again. I did that one by accident, and I apologize. Okay, but sine, right now, if I'm forced to be in this quadrant, and the only way this problem would have worked, and I'm going to say half the time, we would say we're going to make the problems work out. And the other half the time, you might have a problem that is not possible. I didn't mean to do two not possibles. All right, there we go. Now, if one of these two is negative, which one is negative? I'll make it the 1 because you can never have the hypotenuse be negative. So that's a negative 1. And now I can figure out that angle. Did you say 45? Close to 45, though. What is it? Negative 45. Or if you say it in radians, it'd be negative pi over 4. Because this angle right here is a 1, 1 root 2 triangle, and therefore that's a 45. But you got to remember, you're going down, and you'd have a negative angle in the context of inverse trig. Okay. Whew, that was an intense one. Here's one that's not inverse trig and more normalish. Cosine of some angle is root 3 over 2. Tangent of the angle is less than 0. What's sine of the angle? Notice I don't want an angle. I want to know what sine of the angle is. Pause for a second while I try that. And here's how you should have done that one. First of all, cosine's positive. I know it doesn't say that, but it's the way you should think. That cosine is either positive or negative, and it's positive because there's no negatives. All students take calc, so where's cosine positive? Only in these two. So that makes these guys out. And tangent's negative. That means it can't be here. because tangent would be positive there. So that means you have to draw it here. And that means, let me think now, sine of this angle. I don't know what the angle is yet. I'll figure that out by doing this. Cosine is adjacent, root 3, over hypotenuse, 2. Then this other side must be a what? A 1. And in fact, in the context of this, it has to be a negative 1 because it's going down like that. Awesome. And then that makes this a 30-degree angle. I got that one memorized. Awesome. So do I put 30 or negative 30 or something else? Why isn't it negative 30? Why isn't that okay? You're right. We really don't need the angle. But if they had asked for the angle, I just want to clarify, this is not an inverse cosine question. Okay, and therefore we'd not say negative 30. We would say all the way around here, which would be, if we're going to do radians, a whole bunch of pi over 6s. Not quite 12 pi over 6, so you back off 1 and it would be 11 pi over 6. But you're right, we wanted sine of this angle. The sine of the angle is opposite over hypotenuse. Here's the opposite, there's the hypotenuse. Negative 1/2. And I bet if I was going to mark things wrong, more things would be wrong because of that negative than anything else. It's so easy to forget direction. So careful with your negatives and trig. Yes?
Would points be taken off if it's say negative pi over 6?
Yes, because the question wasn't what is the angle. The question was what is sine of the angle.
Yeah, but if it was what is the angle?
Okay, if the question had been what is theta, and you had said negative pi over 6, yes, points would be marked off because that's not, you're not allowed to use negatives unless you're in the context of a inverse problem, inverse sine, cosine, or tangent. Okay, so it's a good reminder. What's this spot right here? Well, it kind of depends on what unit you're in. That spot right there could be 6 pi over 6, 7 pi over 6 in normal trig. In vector land, it would be negative, what would that be? Negative 5 pi over 6. In, let's see, what's the other kind where it's polar? In polar, it could be either 1, and they'd be okay with you saying this dot right here as having either, let's say the length of it was 5. You could either say 5 comma 7 pi over 6 or 5 comma negative 5 pi over 6. Either one's okay. In inverse trig, what's true about this little area over here? It's a dead zone. Nothing can exist there, so you wouldn't be doing an inverse trig problem there. All right, so it really depends on what unit you're in, whether or not you can use negatives or whether you have to use negatives or whether you can use either one and be fine. All right. So, did we already answer this? See, I think we were done with that problem. So, all right, moving on. I want to just pause for a moment and let you ask me questions. Is there any topics that you're a little uncomfortable with, a little nervous about, that you want to talk through? Yes. In the far. Okay, so if we had, did I already do this problem in this class? Conjugate of? Okay, good. I did it in other classes, so I'll do it with you. So let's say we say z is 2 sine of pi over 6. You remember how that's can be written as x and y coordinates? Right now it's in, oh, I'm wrong. Dang it, I meant cis. Sorry. Cis. Okay, that is an equation for a complex number, okay? And I can find its conjugate. We'll do that in a minute. For right now, though, just find its rectangular coordinates. Some kids did this by graphing last hour. Some kids did it by actually multiplying out cosine plus I sine of the angle. Personally, that's the way I kind of would gravitate. But if you're more of a visual person and you want to actually draw the picture of where that is, that'll work. Either way, find me the rectangular coordinates, like root 3 plus I, or whatever it comes out to be. Then, once you've got that, would you please find its conjugate? Not multiply by its conjugate, just find the conjugate. Once you've got normal z, find conjugate of z. Did you finish?
Yeah.
Sweet. With time to spare. Pause for a second. All right, so you should have said cosine of pi over 6, which is cosine of this triangle. Let's see, root 3, and then cosine's adjacent hypotenuse is root 3 over 2, plus I times the sine, which is opposite of hypotenuse, is 1/2. You multiply the 2 into both things, and then the denominators cancel. It's root 3 plus I, and I told you ahead of time what it was. How many had it right? Okay, good. Then, what's its conjugate? It's just root 3 minus I. What's the magic of conjugates? When you multiply them, they don't just turn into 0. But when you multiply this times this, remember how the outside and the inside do something special? They cancel. And therefore, it's really just down to the firsts and the lasts. Go ahead and figure this one out. The conjugate of z times z, this one's actually z, z times the conjugate of z comes out to a nice number. It gets rid of the I, which means it gets rid of the square root. Do you remember that whole, like, we had 1 over I in some of our problems, and we were like, oh, that's not okay, because we can't have an I in the denominator, because that's a square root in the denominator. Anyway, have you FOILed this out yet? What were the first? Square root of 9, which is 3. Then the outside and the inside cancel, because they're exact opposites of each other, so they're just gone. And then the lasts make negative I and positive I, which makes negative I squared. Can I leave it like that? No, because I squared is really what? So 3 minus negative 1, which makes 3 plus 1, which makes 4. Raise your hand if you had 4 for your answer. Okay, good. So that's one of the things conjugates are good for, is multiplying things out so that they end up with nice, clean denominators, so that the denominator, in this case, if this had been a conjugate, so that to clear the denominators don't have square roots in anymore, it's just a 4. Okay, so that's the concept of conjugates. I have one more that I want to talk about. Let's say I had this big, scary looking thing. You are the master of these now. They are not your master. That would be a big wave. What's its amplitude? The amplitude is just 5. What else would you know about this guy? Yes. So what does that mean in the context of the cosine used to look like this and go like on forever? This thing's been shifted up, and its new dotted line running down the middle, which would used to be like right here, is now shifted up with it. So if this goes up here, it's been shifted up, and how far up is that dotted line? Yes, because it's a 4 right here. All right? Is that the phase shift, yes or no? No, it's not. We have to do something first, and then it'll be the phase shift. What do we have to do first? Pull out the 2. 2 goes out front. What do you got left? X minus pi over 2. How do you know that? Because when you multiply it back out, you get this. See, 2 times the x makes 2x. 2 times the negative pi over 2, the 2's will cancel, and you get negative pi. Yay. Why did I do that? Because that's the phase shift. The phase shift is pi over 2. And what's its direction? Because you can shift things this way or that way. It's to the right because it's a minus in there, so it's right pi over 2. Okay. What's the b? The b term here is 2. And last thought, if you know the b, you should be able to tell me the period of this complicated looking function. What's the formula? Period equals, period is 2 pi over b. If this had been tangent, by the way, it wouldn't have been 2 pi over b. It would have been pi over b, because tangent has a period that's smaller. Okay, and then period is 2 pi over b. If the b is 5, oh, it wasn't, b isn't 5 though, it's 2. Sorry, b is 2. There we go. Then it's 2 pi over 2, which means the period would be what? Pi. Okay, last thoughts. What would you do to study for this final? Tell me something you might do in the last hours before this final or the night before it or whatever for the next few days. Yes?
Go back to like do the homework and find the problems that we did for class.
You can do problems we skipped previously. Good point. And the answers for those posted too, so that helps. What else you got? Yes? Good. Watch the videos that have been posted, and you can use the keys to check prior problems. I bet you if you go back and do a problem even from a week ago, you won't remember doing it. You can try problems again. Check them. Don't forget that I recorded videos in different hours. So like on, like the last few videos, there might be an hour 2 video. Well, you're in hour 4. You could watch the hour 2 video or the hour 3 video from past days. I did different examples in there. So, okay. But there's only one of today's videos, so don't go looking for other videos from today. That's all I have for you for today. I'll be looking forward to seeing you again for the final.